Hi everyone, my name is Mark Vinciguerra, and I'm a Specialist Solutions Architect at AWS on the ML Frameworks team. And today I will showcase how to efficiently orchestrate multi-user AI/ML training and inference jobs on a SageMaker HyperPod cluster orchestrated by EKS. This is a 3-part video series where each part will cover the following ideas: overview of key ML concepts on AWS, distributed training on HyperPod, and inference on HyperPod. This video is the inference segment. Therefore, let's pretend I am now on the inference team and deploying a different workload on the same HyperPod EKS cluster where our training team deployed it on. For our job, we will be utilizing the HyperPod Inference Operator. The HyperPod Inference Operator is a robust Kubernetes operator that enables deployment and management of machine learning inference endpoints on your HyperPod EKS cluster. Its features include one-click deployment capabilities, so the operator enables simple deployment of over 400 open-weight foundational models from SageMaker JumpStart with just a click, and supports deployment of multiple sources like S3 and FSx for Lustre, while handling all the infrastructure complexity. It also has built-in autoscaling and resource optimization. So the operator provides native autoscaling capabilities using CloudWatch and Prometheus metrics, and enables efficient resource utilization through HyperPod task governance by allowing both inference and training workloads to run on the same cluster with priority-based scheduling. Finally, it has comprehensive observability. So the operator automatically publishes key metrics from multiple sources like inference containers, NVIDIA DCGM, Kubernetes nodes, all to Amazon Managed Service for Prometheus, and visualizes them in Grafana dashboards, providing deep insights into inference workloads and your cluster resources. So again, at this point, I'm now on the inference team, and my goal is to submit an inference job alongside the training team on the same cluster. We could see our training team's job is still running. And for our job, we'll be submitting this job in the inference namespace. So let's look at the YAML that we'll be applying. Again, this is using the HyperPod Inference Operator. It is of kind JumpStart model. There's our model name, and then these are the specifics to submitting it in our task governance inference team namespace and allocation. So we have our namespace, queue name, and priority class. This is also the SageMaker endpoint that we are going to be creating, Mistral Autoscale endpoint, and we'll be deploying a Mistral model. This is the model ID, so directly from JumpStart, this model is going to be deployed from. And our instance type that we're targeting is the G5 8x large instance. We have also set up pod level autoscaling onto this. What do I mean by this? Right now, our deployment in the inference operator is going to be looking at CloudWatch metrics. And depending on those metrics and depending on how many invocations that our deployment gets, it'll scale out or in. What we're saying is it's going to be a minimum of 1 replica, so 1 pod deployed, to a maximum of 4. And it'll be looking at our CloudWatch metrics. Its goal is to have a target value of 5 invocations per second on each pod, and it will scale depending on this value. So we can deploy this model. We can run inference, deploy JumpStart, submit JumpStart. And what this is doing is just a kubectl apply. And we can see it's created. How do we make sure it's running properly? So we could see it's initializing our pod. This means it's pulling the container image. And what it's going to be doing, once it's running, it will start provisioning, automatically provisioning for you a load balancer to help direct traffic to the model and then eventually give a response back to the user. So we'll wait for this to run and deploy the endpoint. And this takes a couple of minutes, so we'll probably cut and come back to it. But yes, let's let this happen and make sure when we come back, it's successfully deployed. Now I think we've waited enough time. Let's check our deployment. So we can describe the deployment, and we see that it is of type creation completed. And to really test this, we can invoke it ourselves. So we can run a Python script called invoke JumpStart. And what this is doing, it's reaching out to our endpoint and has the input, hi is water wet. So we can run this and see what the model thinks. So it looks like it's running properly, it's deployed properly, it got our input, and is giving a response with its own interpretation of it if water is wet. So this is running properly. Now at this point, let's look at what our cluster looks like from a high level again. So when we look at our cluster now, we still have the training team's job running using the 8 GPUs, and now we have just deployed the inference team's job. Right now, this inference team is just using 1 GPU, so it has 2 remaining anyways. It could just use one of those 2. So right now, the training team's job and the inference team's job are running in parallel. But what happens if it becomes a busy day for the model and it might have to scale out to those 4 maximum scaled out replicas? Then what happens? How does task governance react to this? Who gets what compute? So let's test this out now and see what happens. So the way that we can make our model automatically scale out and our deployment automatically scale out is by running a load test. A load test is a script that's going to send a bunch of requests all at one time to our deployment. And it's going to trigger those scaling events to hopefully get to those 4 maximum replica pods that we set in our configuration. So we can have in one terminal watching our pods. And we can create a new terminal. Make this even. And in this one, we are going to be running inference load test JumpStart. So we run this. We can see it is requesting a lot of hi is water wet to the model. And now we can see it's just added 1 more pod as the requests are coming in. This pod is now initializing. And now it's added 2 more after that. So now we have 4 pods that are soon to be running for this deployment. And yes, this is it. This is our HyperPod Inference Operator trying to handle all the busy time of this, the load test. And eventually, when it realizes that there's no more requests coming in, it'll scale down resources so the training team can resume the job. But yes, right now it's scaled out. Let's see what happens to our training job. So there's a couple ways we could check on this. First, we could describe our HyperPod PyTorch job. So we see the job was preempted. The job was suspended after creation. It was preempted due to accommodate another workload, this workload ID, which would be the inference workload. So we could see that after describing the HyperPod PyTorch job. So if we go back to the console, we could also go back to our HyperPod dashboard, press on the Tasks tab, go to our training operator, and we see it's suspended. So this is how our cluster looked like before. Now with the auto-scaling event, the inference team took up 4 GPUs total. This is them reclaiming their guaranteed compute. They originally guaranteed these 4 nodes, or these 4 GPUs, so they have the right to reclaim them back from the training team, as the training team was just borrowing them. So this is what our current status of the cluster looks like. When it goes back down and the deployment realizes that there's not enough requests for this amount of pods, then it will scale back down to 1 pod for that inference deployment, and the training team will then just automatically resume its job from the last saved checkpoint. It doesn't have to restart, it'll just auto-resume from that last checkpoint. So now it's been some time since we last ran the load test, so it's probably cooled down from now, and we could check this by looking at our pods. I've run this before. And nice, we have 1 pod for the missile deployment. But now, what happens if another team wants to run an inference job? This job is a DeepSeek model, recently fine-tuned by the training team, but now we want to have another team deploy this model for inference. So since it was recently fine-tuned from the training team, this model is now placed in the S3 bucket rather than in the JumpStart model catalog. So with it being in the S3 bucket, we can have a new type of inference deployment config. Still using the HyperPod Inference Operator, but now instead of deploying from JumpStart, we're deploying from S3. And we have the same exact auto-scaling configurations that we've set. So min replicas is 1, 4 is the max. It's going to be looking at our CloudWatch metrics to decide when to scale out or scale in. And here we're saying which S3 bucket our model is in and where to find it. So to deploy this, we can run submit DeepSeek, which is just another kubectl apply with our environment variables substituted in. So now we can check our pods. And it is starting to initialize. Same thing, it will automatically provision the load balancer, create the SageMaker endpoint. This will take a few minutes, so we'll pause here and then come back when it's deployed. So now at this point, we waited some time for the deployment to run. Now we can check the status. Check. So we see we have a running pod. We can describe the endpoint itself. And we see the deployment's complete. Describe SageMaker endpoint registration, creation complete, and we can even look at the logs of the pod. And we could see here that it downloaded the model from S3 into GPU memory. And now it is ready for service. And to really test this, we can invoke it. To do that, we'll run invoke DeepSeek. Same question, is water wet? It replies, I've heard that water is wet, but I'm not sure if that's true. I think it's because water is made and then that was the max context. But yeah, it seems like it's working. That's good. So now at this point, we can look at our cluster again from a high level quickly. Now we have 3 teams running a job each in parallel. We have the training team running their training job on 8 GPUs, the inference team running the Mistral model on 1 GPU, and the DeepSeek team running the DeepSeek model on one GPU. So now all of our persistent G5 8x large GPUs, this node group, they're all being utilized completely. There's no idle GPUs, and yes, everything's running in parallel. But what happens now if the DeepSeek team goes through a time of a lot of invocations? They have a lot of users that are making requests to the model, and they need to scale out. Same type of test that we did on the Mistral inference team. What would happen now? So we're going to test this. We're going to do another load test on the DeepSeek team. And if you can maybe guess it, this is where we'd be using Carpenter. This is managed Carpenter by HyperPod, and this will kick in the Autoscaling group. So let's demo this. So now we're back in the console, and quickly I wanted to show how we kind of set up our Autoscaling group. So there's something called a HyperPod node class, and we've applied this already. But this is pretty much just saying this is the instance group that we want to associate with the autoscaling in general. So we're saying we wanted these different instance groups and these different AZs to be able to be autoscaled. And we also apply the node pool. The node pool is where we set up our rules for autoscaling. Basically, our rule here is if there are pending pods, then spin up these GPUs, these G5 8x larges. There's many different types of rules you could put in. You can put in a min-max number of GPUs to put in, how long to wait until to start spinning up GPUs, when to scale them back down. We have a lot of documentation on this, which we'll also link under this video. But now let's do the load test. To do this, we can run inference and then load test DeepSeek. Right now it's sending a bunch of requests to the DeepSeek model. And we can watch the pods. And now we can see the pods are starting to get created. They're in pending state, soon to be in initialization state. But yes, let's look at the pods right now. So if we do kubectl get pods and describe one of them, we can see that they are in pending state because now Carpenter is nominated, and it's saying this pod will be scheduled on this node claim. So it's waiting for the nodes to be provisioned in order for the pods to land on these nodes. And we can look at this in our console. If we go to instances, and we have a number 2, we are now starting to get some instances being provisioned to accommodate those pending pods. So this is automatic auto-scaling by HyperPod Carpenter. And it's recognizing we have these pending pods, requesting for these GPUs, and we have auto-scaling enabled for this instance group. So it's allowed to auto-scale and provision these nodes for these pods. And once these are provisioned, we'll cut back to that and show you. And same thing, once it cools down, it realizes that there's not enough requests. It's a slow period. The pods will scale back down, and Carpenter would scale back down the nodes as well. Now we can see our pods are initializing. This is because Carpenter successfully scaled up some instances in our autoscaling groups. Thank you everyone for watching. I hope you learned something about AI ML on AWS, training on HyperPod, and inference on HyperPod. As the next step, I'd like to shout out this resource, AI on SageMaker HyperPod. This is a repository that provides optimized blueprints for deploying high-performance clusters to train, fine-tune, and host AI models on Amazon SageMaker HyperPod EKS and Slurm. I'll also post a link of these and other references from each video in the description below. Thank you all so much.